microservices are not a new, they're not a new thing. It's a fairly old idea. It's being applied to the cloud space. So what we're going to talk about today is microservices as within the cloud context of basically you have small servers that all interoperate to create kind of a larger behavior of a larger system. Whereas previously you might have a lot of monolithic type of architecture where you'd have one big thing that handled all your orders and all your customers, and you have another big thing over here that handles all your payment transactions and things like that. Microservices breaks it into discrete little pieces. And so I'm going to go over why that's a good idea and kind of the different approaches that people take with it. So microservices are cloud servers which provide access to a single resource in a distributed computational system. So we're really kind of isolating our concerns here and making sure that our code is really responsible for interfacing with one major component. And so it makes things easier for reasons I'll outline. And the second piece of it is kind of the overall trend in computing to be more decentralized, to move away from the large monolith code bases into smaller pieces which are composable and reusable, and easier to reason about. So what's handy is to say what we're not going to talk about today to kind of limit things. I'm not going to go over specific platforms and frameworks. These are kind of architectural principles that can be applied to any cloud service or with any languages and libraries and stuff. I myself use Node and Python for these things, but there's a Java approach, there's a .NET approach, there's a you probably want to use C++ for this kind of thing, but there's a variety of ways to approach it, but I don't want to talk about that here. So this is about distributed computing. So this is multiple servers living in a cloud. We're not talking about modular to a single software system like Linux, because that's fairly modular in that there's a bunch of little pieces that all operate together to create a bigger piece. And also containers. If you're familiar with containers and their kind of role in the development ecosystem, they are very useful for microservices because they let you define how things talk to each other and how things are all set up and easily reproducible. So they're definitely part of things, but I'm not really going to go over it too much. So let's go. So this is what credentials me to talk about these things. I was recently a software architect and developer lead at Mobilize. We do computer vision and hardware, and now I've taken over product responsibilities. And then I can be reached at 8eyes at PDX Slack, and I'll put this presentation at GitHub in the end. It's using this wonderful JavaScript library called Reveal.js. So all these slides are live as one big website, and uses this software called Reveal.js to just turn it into a presentation. Maybe that didn't go. Okay. Anyway, so let's go into kind of what a simple microservice would look like. Okay, so this is my problem. Twitter won't let me do a client-side search via GET requests. They want me to go through an API for their own, so they have a key, and so they're not going to get throttled. They're not going to get bombarded with a bunch of things. So they want me to use an API. So in my broader application, I could just build this Twitter search into the larger application, provide it as an endpoint, and then got to manage authentication, handle the API keys, and all that stuff. It's not significant complexity, but some complexity to add to a larger system. And so, but there's an alternative. We could just have a microservice for this Twitter search, and which would just be a simple server to forward a request to Twitter, and then Twitter would respond back with the results, and then so all the things like authentication happens as part of a data pipeline. So the same authentication you would use for the rest of your application, you would just use that same authentication microservice to authenticate your Twitter call. And so you have that, it's kind of that don't repeat yourself type of idea where you have everything is kind of living in one place, and you don't have a bunch of duplicate code all over the place. And so that stops bad calls from reaching the microservice, and then APIs get provided to the container by the Docker or whatever's running it. So it's kind of like an example of the way you would approach it with a larger application, and then the way you could approach it with a microservice approach. And so let's go into something a little more, a little more complicated, some more real world use case. So we have a client, that say they're doing something like, something like Netflix or something like that, where they have their information scattered across different databases because different databases have different functions. So, if you want something flexible, you'd use a NoSQL like Mongo. But if you want something that was really kind of performant for large table databases, then that could all be an SQL. But then if you wanted to build intelligence on top of that and figure out, okay, well, this person here liked this movie and this person here liked this movie, what's the intersection of a movie that they're going to like? You'd use something like Neo4j as the graph database to build that connection. And so, so then it comes down to, okay, well, how do I reason about this in a larger system? I mean, it's basically, I'm going to make a request to this. So yeah, putting all this business logic into a single code base you can do, but it makes this hugely complex thing you have to deal with. And that server is tied up the whole time that it's making these requests. So even if it gets the Mongo and SQL queries done quickly, the Neo4j might take a little while. And so the server just kind of sitting there waiting for that request to finish. Well, that's not good. That's going to make it so that server is not available for other users. And it's going to make it so you have memory problems down the line, and eventually your servers are going to go down without having as many users. So the alternative is to have several microservices that you're using, one for each, one that's connected to each database service. It's connected after that via kind of an event-style messaging to basically return the results back to the client. And so this is kind of what that looks like as a simple diagram. Is you have the client, they send out a request, it goes to kind of a routing gateway that sends off the different service requests, and then those all get funneled into an event loop that's just kind of sitting there waiting, and then those all get sent back to the client when they're done. And that's usually the way I do that is usually with WebSockets, but Firebase provides a nice approach for that too. It's basically, but it has to be a separate channel, distinct from the request. I think it's on the next slide. So we're going to kind of talk about the difference between transactional requests versus streaming requests, and they both have a role in the microservice world and in development in general. So the REST/remote procedure call, remote procedures actually go way back to the 70s, as that was like the original idea of how do you interconnect software is how you basically calling functions from in different software packages from each other, and then that all kind of got replaced with our modern web world, which is kind of REST, and now we're starting to see RPC come back, which is kind of exciting to be more. It's a little bit more of an interesting way to compose software, but yeah. Send a request, and it's two-dimensional. It takes, it's asynchronous. It takes time. It usually involves, external APIs, database access, and it's very ordered. It's like one thing happens, another thing happens, and another thing happens. And these are all kind of dependent upon each other. The other approach is with streaming, which is basically streaming is using messages or PubSub to basically kind of broadcast your messages around. So one message could be received by several microservices. So if you had like a request come in, that same request could go to your different microservices, and then each one would pull from that request what it needed to know to make its operation. So the big difference with streaming is it's one directional. You don't get any sort of authentication going back, or acknowledgement going back. You have to kind of manually build out your acknowledgement pipelines, and those can be a pain because there's messages drop and things like that. So you have to kind of put a unique identifier on the message before you send it, and then make sure that that unique identifier is received on the other side. So it's it can be complicated to build a transactional system in a streaming manner, but a big part of the benefits you get from microservices are doing these kind of streaming-based approaches, where information is going one way and then coming all the way around. If this was going to be a kind of a transactional thing, the client would send the request, and then the request would send right back to the client. It's just a single point of information going in and information coming out.
Which part is going in on the cloud? Which part is on the machine? The gateway is in the cloud.
Yeah. So the request is kind of ephemeral. The gateway would be in the cloud. The services, services would be in the cloud, and the event loop would be in the cloud.
So the services of microservices behind the gateway.
Yeah.
Oh, okay.
The gateway is pretty much because you don't want to wire up your application to talk to each microservice. You want it to be kind of behind a proxy. So you're sending all the data, all the kind of requests to a proxy, and then the proxy kind of is the traffic cop and routes them to the appropriate services. And then the event loop kind of standardizes it on the way out.
So is gateway and program have to code it, or it's a queue kind of thing?
That's a thing it's usually either in the cloud services, kind of they have an interface for that kind of thing, or you code it yourself to just kind of interoperate in that way. So usually we end up just coding it ourselves because it's just simple routing, pretty much.
Okay.
So that's clear. So the big difference again for streaming is kind of like for operations, and when you're doing things in parallel, where the Mongo database operation doesn't necessarily need to know about the SQL database operation. Then you can do these things in parallel and just reconstruct the records after the fact. And so, or for, because I work in IoT, and so having a way to kind of distribute the writing of data, because we have a lot of data coming off of a lot of devices, a way to kind of distribute that around and not make it so a device has to be worried about whether or not something has been written. That's a big help. Because otherwise, a device would say send, 100 data points and then wait for a response, and then send another 100 and wait for a response, and then so it's just sending, and then in production we make sure that we have the device actually check the database to see if things have been written before actually deleting the data off the device, but that's different. It's kind of like a
another string.
Yeah, well, that's more of a response, and that's the point is microservices can use both, or they should use both, because they're different. Transactional and streaming are kind of two different tools for your tool pack, two different approaches to how to build these things. And so, okay, so I'm going to go a little bit into the history of kind of where this came from as an idea, just to kind of try to connect it to what you might know nowadays. So at the very beginning, we had punch cards. It was very straightforward, machine code, just like A to B to C. And if you wanted to go somewhere else, you had to actually explicitly say, hey, go to this memory address or go to this line of code. It's great, so it worked for simple things, but when it came to more complicated arrangements, it gets really out of control, because all of a sudden, what happens if you move this piece? You got that was back in the 60s and 70s, and way before we have what we have nowadays, which is a procedural approach where we can abstract things into functions, and we provide kind of interfaces with headers. And so this is kind of what let earlier software architects piece together programs that were more moderately complex. And then I think it was the 70s or 80s, we came up with the idea of object-oriented programming with classes, and I assume everybody's kind of familiar with that. How that works, but the big deal there was kind of encapsulation, was being able to hide pieces of your logic that weren't necessary for other parts of your program to know about, because, and I'll go into that in a little bit, but the less kind of tightly woven together things are, the easier it is to work with and to maintain and to even build, because it frees up your cognitive mind from having to worry about all these connections. And then kind of in parallel with the procedural approach is a functional approach. Lisp was out of the 70s too. The modern approach is Clojure, and if anybody's familiar with like kind of reverse Polish notation on calculators, we're separating we're actually functions have the same kind of importance as variables and objects, in that you can just stick a bunch of functions together and then put a value into the first part, and then that value will process through all the functions. So like something like a Fibonacci generator or recursion is kind of an example of a functional approach, where you're taking a function and defining it and then putting it inside of itself, and then it just calls itself over and over again to get to your point. So JavaScript is even a functional language, in that functions are what's called a first-class citizen. Functions are objects in JavaScript, and so it lets you do some really interesting things in as far as, you know, if you want to have a series of computations done, it can be just a matter of putting a bunch of functions together, and you don't have to worry about how they you know, how the pieces go together. You can just run the functions and take the results from one function, and it'll pass to the next function, and just boom, 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 like that. So and that's kind of where microservices exists in this world, is kind of more of a functional approach. These are kind of small units of logical functionality that just get things done. And so yeah, so if anybody is familiar with kind of the classical software architecture, it's related to kind of the interface pattern, where you don't want to expose your application to all the complexity that lies inside of services, so you use an interface to access that service. So that's the big word right here, is decoupling. That's the big reason why you use microservices, is to do things with a strongly object-oriented approach and build your monoliths. You have a lot of things that are tightly coupled. You have a lot of classes that are just kind of woven together, because that's just the nature of how it works. But when you have a bunch of discrete components that are spread out in a modular way, that allows you to have things decoupled. And that means that, you know, when you make a change over here, the impact in other parts of the system is much less, or it might even be non-existent if you have, you know, proper documentation, change management, and things like that in place. So, like I was saying, so for maintaining your software, you know, it's like it's great to just build it once, but you know, someone's gonna have to go read that code, someone's gonna have to go understand that code later, and it might not be you know. And so we have to make sure that we're writing code that can be maintained. And so, like I was saying, coupling is a measure of how brittle things are when they're put together. And the ideal we're striving for is to have things what's called loosely coupled, where we have just enough to woven together to function, and so we don't really have to worry about all the inner workings of each service. So, like I was saying, yeah, each class, you know, they aren't necessarily tightly coupled, but as you know, development progresses, we face a situation where it adds more complexity and things get more tightly coupled as we go along, unless we explicitly try to make things get more detached. And so microservices encourages better software architecture because it includes the edges. And the edges are the seams between the software. And as long as those are clearly documented, then anybody can just kind of jump in at any point in the whole, you know, in the whole system and, you know, be productive or fix things. It's also helpful in a scalability standpoint. You know, because if you consider a typical CRUD service, you know, that just accesses the database, create, read, update, delete. I'm sure we've all made a few of these. But in most applications, you know, read is the primary the primary use of this. And if everybody's reading, that's going to impact on people's ability to create and update. And so a microservice approach on this would be to separate out read as a standalone service and scale that independently. And so you could have, you know, if you had a lot of people trying to read your database, you could just say, okay, I'm gonna just add 10 more read services, and then I don't have to worry about the create read, because, you know, those can stay at 1 or 2. And so it lets you kind of scale your application based on use. And so I like that, because it lets you kind of adapt. You know, when you start a project, you have a bunch of assumptions about how it's going to be used. But then once it's out in the real world, it faces users, you get some actual data about how it's being used. And so then you can kind of change it around to be, better for the use case.
Push for 5 minute.
Okay, well, I'm almost done anyway.
Okay.
So wrapping up, kind of some important considerations to think about, apart from the stuff I've already been talking about, just kind of the things that maybe the warnings of microservice approach is logging. If you have a lot of servers going on, a lot of software going on, you lose the ability to just kind of have a debugger that's just watching this one giant stack, and so that if you're trying to track down, having a logging and clearly monitoring what's going on, that's something important to consider. How are you going to do that? There's a number of approaches. Like I was saying, edge documentation to basically to ensure that you can be functional and other people can be functional. The documenting these things and showing how they operate within the system is very important. Otherwise, it just gets kind of overwhelming because you have 20 different servers and no one knows how. Everyone just is responsible for one or two, and no one really knows how they all work together. So the documentation aspect of this is pretty critical. The choice of tooling in the cloud provider. So Microservices is great because you could have PHP and Node and Python experts all working together on the same system. If they're all building their separate microservices, as long as the messaging between the pieces are defined, then it doesn't really matter, and you can kind of adapt to people's skill set and whatever is necessary, the use case. However, running the stuff in the cloud is complicated, especially if you have the whole a large Docker instance with Kubernetes and all the stuff. It gets complicated to have all the stuff be put together. So before jumping off the deep end on it, definitely get your feet wet in your cloud, AWS or G Cloud or whatever, before you really dive into it. And part of that is kind of the health check. It's kind of a just an endpoint that says, hey, 200, this application's okay. And that's it. When you have all these applications running, it's just an important thing to consider. So anyway, that's microservices. Thanks for listening.
Thanks, John.